Hi everyone, so welcome. This is just a quick stream really, a little preview of later on stream. I'll be live at 8 o'clock later on. It's just the way my day's got to work around, but to give you some tips of what you should be focusing on, how you can be revising today, which is the day before your paper 3. So here's some really things that I would suggest that you make sure you do. You make sure you know the exact type of questions that your exam board does on their paper 3. So you review some paper 3 tests that you've already done probably, or past papers, or the specimens, and you know exactly what that's going to look like for you, what types of questions they're going to ask. Okay. Then also use the how science works, or the practical skills, or the experiment skills, whatever you've got in your own textbook or the specification for your course, and actually really use that to know exactly what your exam board defines uncertainty as, exactly what your exam board defines error as, you know, that type of thing. You know, what are the kind of definitions, what are the stuff you're really expected to know for your exam board. I think that's really, really important. Use your revision guide, use the scheme, use the specification, use your textbook. Look at that practical skills section of your course and really make sure that you kind of just know it inside out. And then I would advise you to keep it reasonably chilled today, and that's really the purpose of this stream. Is one thing I think is a good idea that it's the day before, is to do some quite leisurely watching over YouTube stuff, watching over stuff that's reminding you for stuff, you know, making sure that you know exactly what's going on, just sort of getting your memory going, not really over stressing it and thinking to yourself that you're going to cover loads of exam papers today, because today's the night before and you need that energy for tomorrow. So I wouldn't overstress it today. Now if you've got any last minute kind of queries, then go ahead and put it in the description, in the comments below. I am going to talk through just quickly some videos that I suggest that you watch today during the day, that you kind of, you know, maybe take a few notes from, you know, just think through, yeah, I know that, oh, that's a bit new, I'll have to have a little look into that, exactly what my exam board says of that. Right, so here's the list of suggested videos. So I suggest there I suggest this one, especially if you're Edexcel. Now I've got videos for Edexcel, AQA and OCR, all of the practicals, and I suggest you actually watch all of them, okay, all the different exam boards, because sometimes they can be variations in the practical which can really help you for those slight differences in the practical that comes up in the exam to maybe the one that you did. So there's the Edexcel one, all of the Edexcel core practicals in one videos. Now, especially for Edexcel, there's loads of derivations in paper 3. Okay, now you'll have to tell me if AQA or OCR have that many derivations, but there's all the derivations video as well. And all the laws and principles, a big idea. Okay, that is a very good video where I go through all of the laws and principles that come up in A-level physics. So I think that's a really, really useful one, and I certainly suggest that you use that one. Then the last one over here is the Edexcel paper 3 playlist. So that actually runs through an actual exam, you know, a full exam with loads of different types of questions. If you're not Edexcel, that still might help you for the practical skills bits, but maybe the types of questions might be slightly different. But I suggest that it would be a really, really good video to go through, especially if you're Edexcel. If you're OCR or AQA, then I still think it would be quite good. And then if I just jump over to the other side, then doesn't even matter, but you know, it's nice to point. This one up here at the very top is all the AQA practicals, okay, which I streamed just the other day. All the OCR practicals are just there, okay, and then all the my live stream I did for We Cracked the Exam Board Secret Code for paper 3, that's there, that's really, really good. And Dr. Lemon's Trick to paper 3 is there as well, and I run over uncertainties in Dr. Lemon's Trick to paper 3 just there, so that's worth going through if that's what you want. And also my practical physics playlist, which has got actual in detail practicals where I actually do you know, some real in-depth, and I go through and I show some of the practicals. I haven't done all of the practicals, some of the practicals in loads of depth with the actual apparatus, and we discuss them in a lot of detail. All of these kind of live streams are pretty darn good. Okay, I hope that's really useful for you. There's loads of detail about some practicals, and there's a kind of summary of every single practical for AQA, for OCR, and for Edexcel. And I really do definitely suggest that that is a good basis for your revision for today, for just the day before core practicals, for the day before paper 3. Now, loads of people talking about, uncertainties again, and that is a big thing. And I actually had emails from teachers who have been watching these live streams saying, what are we saying for uncertainties? Is it plus or minus half a scale division or plus or minus a full scale division? And I don't know why that's become such a big bone of contention, but especially because the exam boards have realised that people are worrying about that, and they've just said, no, we'll accept either. We'll accept plus or minus 1 scale division, plus or minus half a scale division. So just all of those percentage uncertainty marks are for, therefore, actually the process of working out percentage uncertainties. So yes, you could say plus or minus half a scale division. You could say that means, if it's plus or minus, the full uncertainty is 1 scale division, or you could say there's plus or minus half at either end, so it could be a full 1 scale division out. There are loads of different ways to argue with them, and actually all the exam board, all the mark schemes actually say a sensible absolute uncertainty is what you need. Okay, just a sensible, if you're using something way bigger, then that doesn't matter. Okay, so I'm going to kind of leave it there. All of these links are in the description there, and do go ahead, look through those, especially if you're Edexcel, then there's the Edexcel playlist, especially if you're AQA, then there's the AQA, especially if you're OCR, there's the OCR one, but also I think they're useful for the other things. Have a little go through those, and let me know in the comments if you've got any last minute queries, any bits you want me to go over, if I can ping you a video if I think there's a good one, or I can actually talk about that later on at 8 o'clock. Little bits of chats. What's the topics that can be assessed? Basically the whole thing, but it's like laws and principles. So that's why my Edexcel laws and first principles in physics video is so good, because it goes over all of those big ideas in physics that are likely to come up in paper 3. Yeah, you're expected to know the uncertainties for meter ruler, things like that. It's basically just use a scale division or use half a scale division. Absolutely fine. Yep. Okay, yeah, and you're talking, Finley here is talking about the uncertainties of it. Yep, that's perfectly fine. That's absolutely accessible. That's absolutely sensible, Finley, the way you've done that. Half a scale division over the actual measurement times 100 to give it as a percentage. That's absolutely fine. Remember, if you're compounding uncertainties, you have to add percentage uncertainty, not add the absolute uncertainties. Okay, I think that's all, everyone. What's the difference between accuracy and precision? Well, accuracy means how far away from a true value you are, and precision is a measure of like the scatter of repeated results, is the basis of way of doing that. I always think about this, accuracy is about like the way that you've done it, whereas like precision is about like the kind of closeness, the scale divisions on the instrument. I think that's my best way of doing it. But the definition of accuracy, how far away from a true value is the value you've measured. Precision is a measure of the scatter, how far away are repeated results from a mean, or how far are the points scattered away from a line of best fit, let's say. Okay, Megan, I hope I've said that. It really doesn't matter whether it's full scale division or half of 1. The exam boards are going to accept either. That's not something that we need to actually worry about. As long as you can calculate a percentage uncertainty, as long as you can state, this is my uncertainty, and this is my percentage uncertainty, then just go ahead and do this. Yeah, Epic Me, that's probably a good idea. Especially some of those, I mean, we talk like the live stream, so we do this kind of thing, and we talk about chat. I'll talk through chat, so you can skip sections of that. Okay, somebody's actually, for the Edexcel one, they've time-based, so you can skip to the different core practicals. It's really good. So maybe somebody for the AQA or the OCR one could actually just go through and just do a time-based as they're watching that today. That'd be really useful for other people. Yeah, Jai says use either, but stick to one of them. I think that's quite a sensible argument, certainly within a question. I would say if you've got a reason why you want to use a particular uncertainty, so let's say with timing, then it's not going to be plus or minus half a scale division. That's going to be way too slow with timing with a stopwatch. It's going to be more like plus or minus 0.2 seconds. In which case, well, justify that. Say, okay, I am using plus or minus 0.2 seconds because that's about what human reaction time is, So if you justify why you are using half a scale division or a full scale division, the examiner is going to say, okay, I can understand why. I just follow through with that number and give them all the marks that they're deserved. Okay, again, uncertainty, so that's one of the definitions I talked about there. Uncertainty and error. Definition of uncertainty is the range of readings in which a measurement, a value can be said to lie. So if I've measured something and I've got an uncertainty, then that gives me the range. The measurement is definitely somewhere in that range, is what we know. Whereas the error is the actual difference. So if like, I hope you can kind of imagine a kind of range between these 2 points. If I've said it's here, but the actual value is here, then the error is the difference between those two. I hope that makes sense, yeah. Yeah, exactly, that's what I'm talking about. So that's one of my things there. Make sure you know exactly what your scheme is expecting you to know, definitions, etc. Joe says, go to Appendix 10 on the Edexcel spec, has all the definitions for uncertainty and accuracy and stuff. Yeah, AQA will be the same, but I'm absolutely sure AQA will also have a definition section there. Or if you've got a endorsed AQA textbook, then they will have those definitions that will be as good as the specifications. So it's one of the things we're saying there. Go to those house science work section. Go to your textbook, go to your revision guide for the experimental technique stuff. All the definitions are in there. It's time probably to be revising not just the content, but the actual practical skills really. You'll find that kind of things all over there. All right, so go through the description and look through there and use the links there for those other videos. I want to see those, all the core practicals videos really take off. Somebody's just said to me, I'm sitting down with my packet of Jammy Dodgers and my Monster, ready to fire through this playlist, ready to fire through this all the core practicals live stream. So definitely go ahead and do that. I think that'd be very, very valuable. Don't overstress it, and I'll see you later on for some last minute queries. And I'm also going to do a bit of detail on the viscometer practical, just to give you an idea of some of the kind of evaluative thinking that you need to do with these practicals here. Oh, and I do have a live stream for longer written questions. I think that I'm going to leave that for today, but you can definitely go over that. The key to longer written questions is that you have a little plan with the question. So as you read the question, you think, okay, first thing I'm going to do is answer that bit, then I'm going to answer that bit, then I'm going to answer that bit, and then you can go ahead and you can check through your answer with the question as well. So you plan with the question, then you write your answer, and then you check your answer with the question again, because what we notice as examiners is people tend to just do the last thing that they've been asked to do in a question, and they forget to do the rest of the stuff they were asked to do in the question. Everything you're asked to do on an exam paper is always linked to a command word. So determine, describe, explain, all those different words, they are the clues to where the mark schemes are. Okay, so thanks Call of Duty, that's kind of you to say. I really like A-Level Physics Online as well, however, I think there's, the more people that make these things, the more useful they are for everyone. Huygens principle, Megan, is just a principle that every wave can be thought of as a bunch of wavelets that are interfering to form the next wave front. Just think about that, just say, Huygens principle is interference of secondary wavelets to form a wave front. So Huygens and people at that time were kind of confused why, when you drop a stone in a pond, the wave goes out radially, whereas water waves come as like wave fronts, right? So what Huygens was clever enough to say is that, well, let's imagine that wave is just a whole bunch of little circular waves coming out from one point. They would then interfere with each other to make a wave front, make a flat wave front. So it's saying really that waves are both radial and can interfere to make wave fronts. So that's really what Huygens principle is all about. It's quite an interesting thing, but you're only going to ask certain questions about that really, which is just that secondary wavelets interfere to form wave fronts. Is all you really need to be saying that. That's a good question, Thomas. Is it better to do the option first, then section 8? Can some, what's your advice, everyone? Like, what do you think? I would probably do the bit I feel most confident with first, because that's the way to give myself the time at the end to not panic. When they ask you to evaluate, well, they often ask you to evaluate. Either the results or the methods. So that's what I would think about that. Look in the question. Are they giving you a table of results and they want you to evaluate the results? So things like You know, have they repeated often enough? Have they given correct significant figures? Have they recorded all their raw data? Have they used a large enough range? That type of thing. Or evaluate the methods, which is like, are they using the accurate techniques? You know, based on that kind of accuracy or precision idea, you know, if they use their accurate techniques, then they're going to get closer to the true value. If they use the accurate techniques, then they're going to get more precise data, you know. So think about them as being either you're evaluating the results or you're evaluating the methods, and keep those two ideas quite separate is what I would suggest. Yeah, okay, so that's good, chat. Thanks a lot for that, Victor, giving that advice. Thanks, Harry. I'm pleased to help. Can you make sure that you share this out with your friends as well, all the different ones as well? If you find them useful today, share them out with your friends, because I want to help as many people as possible. Yeah, good chat there. And by the way, Adine, having computer science and physics tomorrow is pretty heavy. There was somebody here yesterday who was saying they've got to have overnight isolation because they're going to do their paper free on Tuesday morning. Wow, that's harsh. Significant figures, the rule is the same significant figures as the least that you measured to. So essentially, for an example, multimeters, you should always be getting 3 significant figures out of them. So everything, including the final result, including the gradient, etc., should always be given to 3 sig figs. Sorry, Astrophysics AQA, I'm not going to go into that too much today, although I have got a few astro videos, but I think I'm not going to be able to do that justice, really. Thanks. Yeah, excellent. Further maths and physics, yeah, so I think that person must have had further maths, physics and computer science all on the same day, so they have to like be I don't know, monitored, isolated, whatever you want to call it, overnight. Could you imagine? Well, that person, oh sorry, I can't remember who it was, but can you come back on Wednesday and tell us how it actually felt? What was it like? Okay, I'm going to put this back just to remind you what this feed is all about. Really, it's just about these videos, but there's nice questions. I think there's one more that I wanted to answer. Why oscilloscope is used as a voltmeter for capacitor discharge feedback? Because the time period or the time constant for that capacitor discharge is so small that an oscilloscope can basically display the curve as a kind of fixed graph, and therefore you know, because the oscilloscope time base can be very, very small, so it's the repetitive charging and discharging using a square wave normally. So let me just say that one more time. So what they use is a square wave, which means it goes positive, negative, positive, negative, positive, negative. So in other words, the capacitor is charging and discharging as it goes positive to negative. Yeah, so it's charging within that time between positive and it's charging when it's positive, and then it's discharging when it's negative. And so you get the little curve graph on the oscilloscope screen, and you can use that as a time base. Even though it is charging and discharging loads and loads of times per second, the oscilloscope is showing you a fixed kind of graph. Somebody's making some really good links, Victor and Adin, right? So I'm going to show them because they look absolutely fine. So look back, there was one earlier on as well, because the YouTube just asked me if it wants me to display things with links because they might be spam. For example, just in case I don't want to show somebody swearing, saying how badly they're going to do tomorrow. Don't particularly want to show that, but I do want to show these links. That's really useful if people are showing things like that. Do share them in the comments, the main comments as well. Will there be questions where you have to explain a certain formula, like an easy form marker? Yeah, but they will be questions like on the big fundamental laws and principles, like you know, like Huygens principle, for example. Okay, I'm going to go now, and I'm going to see you later on. Okay, take your time today. Oh, as I said, there's all of these different videos in the description for you to look at. I think that there's you know, especially those, all the core practicals videos, even for different exam boards, I would sit and binge them today, do any little notes or anything like that. And yeah, so one of them is all the derivations, Ezra. Okay, so all the derivations just there. Okay, but it's in the comments. It's in the description as well. All right, cheers dudes, see you all later.